couple of options. You can either factor this as it is with your x in your box. So you can either do this as our a times c over b, totally fine. Or you can solve it with the square root property. What's our instinct when we look at this one? If we were just asked to solve this, what's our instinct? This one actually won't factor, so never mind, we're not using this. On this one, what we can do is we can actually set this x squared all by itself. So if I subtract 9 from both sides, we'll have our x squared equals negative 9. And what can I do to get my solutions? How do I get x all by itself? Square root. Absolutely right. So we're going to have our x equals, whenever we square root both sides of an equation, we're going to put our plus or minus. And then this is very much like what we did in the bell work. What's our square root of negative 9? 3i.
Oh, I'm sorry. Sorry.
It's okay. Yeah. So those are our solutions. So we're just trying to, when we have solutions here, we're trying to get our x equals, trying to get x by itself. That's what we're looking for. Say it louder. I still don't know what you said. Yeah, for number 4, it's going to be very similar, but these ones we can use our x and box on these guys. So these ones we'll use the x in the box. And on this one, we're going to check for a GCF first. Make sure we check for a GCF because that will make it easier. Because this one doesn't have a C value. What do they have in common? What do they share? An x and a yeah, the 5 and the 10, they have a common factor of 5. So if I take a 5 out of this one, what do we have? If we take 5 into x out of 5x squared, what's left over? X. If I take 5x out of 10x, what's left over? Think division. 2. 10x divided by 5x gives us 2. Okay, that's where those pieces are coming from. This is our factored form. This is factored form. How do we get our solutions from factored form? How do I find solutions? Yeah. We take these guys and set them equal to 0. So my x plus 2 equal to 0. And we also need to do it with the 5x. If it has an x, we include it. So 5x equals 0. That's where we get our two solutions from. So our factors will be our 5x and our x plus 2. What are our solutions going to be? What's our x on this one? 0 and negative 2. So we subtract 2 from both sides. X equals minus 2. That's where we get those two solutions from. So on this first one, it's just finding a GCF. The other two, you're going to want to do the full x and box factoring. That gives you your factors. We've set our factors equal to 0 to get our solutions. On which part? Yeah, on which part? I was say I need more than the whole thing for where to. What's up? Last one on number 6. Yeah, that one's the hardest one. So I'm gonna do 2 of them on there. So it's like there's a lot of pieces in this chapter, so we got to make sure we're keeping track of stuff. So our perfect square trinomial. These guys, when we tell you to use our perfect squares, or if we tell you to use our square root property, that means something's set up as our perfect square. We need to know that pattern. This is not one that comes in our formula. That's when we had something squared at the beginning, which I'm not going to do as yet. So our x squared, we wind up with a perfect square at the end that we usually wrote as our question mark squared, and the middle piece is our 2 times the front times that question mark at the back. That's what we're looking for here. We're trying to find question mark, and we're trying to find C. So I'm going to do the middle one, and we'll do the one on the right, because I know the right one was the one you had a question on, but this one's easier. So our front piece on this one, that's our x that's been squared. And this middle piece, to be able to make our perfect square, we want it to follow this pattern down here. So it needs to be 2 times the front piece, our x, times our question mark. So if I know that our 22x equals 2 times x times something, what does that question mark need to be? 11. 2 times x times something equals 22x. So my question mark piece needs to be 11. Which means C at the end, if I wanted to add a value here, what would need to be here? It has to be our 11 squared. So this would have to be 121. So our C equals 121. So if we wanted to write this as our perfect square form, that's when we'd have our x minus 11 squared. Because this equals our front piece plus question mark squared. Where did I get which number from? The 121. That comes from our question mark that gets squared at the end. So the middle piece is made up of 2 times x times something. That something squared is our C. Let me move the pointer out of the way. New. It's called I have too many things stacked on my keyboard, and my keyboard's getting grumpy. Close. So the right-hand one is definitely the hardest one because it's still following this pattern, but it's not an even number. So it's going to wind up a little fractiony. So we're still going to follow this pattern. This front piece is still made up of an x that's been squared. We're trying to figure out what this piece is so we can square it. And the middle needs to be made of 2 times the front x times something. So if I know that 9x equals 2 times x times something, yeah, it's going to actually be 9 halves. If you set it up as this little baby equation and get my question mark by itself, divide both sides by 2 times x, we wind up with 9 halves equals our question mark. Or as a decimal, it's 4.5. So our question mark piece, divided by 2x, divided by 2x, the x's cancel out. That's why. So the question mark piece is 4.5. So what is the C going to be? This piece that's our C. What's that guy going to be? Yeah, so it's going to be our 4.5 squared, or 9 over 2 squared, so either 81/4 or 20.25. So it's decimally and gross, but that's definitely the hardest one of finding that piece. So if we wrote this as our perfect square, we would have our x that was in the front, our 9/2 that is our question mark, and we use that same sign, so this one gets a plus. Definitely that is the hardest one, and I believe that's the hardest one of those finding the C of the chapter, is that one. That's the hardest one. I have an answer.
So, I can't do 3.
What do you mean?
I can't do 3.
It has to be 2.
It has to.
Has to be 2. That is part of the formula. It has to be 2. This 2 does not change. The front piece is squared, the back piece is squared, and it's 2 times the front times the back. The question number 1?
Yeah, but you do like the last one.
The domain and range and end behavior? Or write the equation?
The domain, behavior, and
Okay. Honestly, at that point, it kind of just makes sense to do them all. So we're going to look at number 1. We're looking at this graph over here. So our first question is asking about our solutions. Where do we have solutions on a graph? Our x-intercepts. So specifically, where are our x-intercepts on this graph? Yep. -1, 0, and 5, 0. These two. So those are our solutions. -1, 0, and 5, 0. And I know specifically this was not the question that was asked, but we're getting our way down there. We're getting to the bottom 3. So where's our vertex? 2, -9. We actually gave you that point. It was named down here. It's this guy right here. My pen is being a jerk. Is it a maximum or a minimum? Minimum. It's a low point. What? My pen is being such a jerk today. All right, where's our y-intercept? -5. This guy right here. All right, so those are the pieces we can read off the graph. Questions about any of those pieces? Okay. Our axis of symmetry, we have all the information we need for it here. Because where is our axis of symmetry? It's where it folds in half, which is always going to go through our vertex. If I was to fold it in half, I would fold it at the vertex. So this guy, our x value here, that is also our axis of symmetry. It's x equals 2. So now we're getting into the meat and potatoes of the questions that were asked. Looking at our domain and range. Domain is asking what x values work. Domain is all about the x's. So how far left, how far right. So with our domain, how far left can we go? -infinity. My arrows are going to the left. How about to the right? Positive infinity. I can use all possible numbers in the existence of the universe. I could go from -infinity to positive infinity, and I could substitute an x in and get an answer out. That's not imaginary. So our domain goes from left to right. Our range, where are we going to get that? The y's. How far down, how far up? So what is the very lowest that this is going to go y value-wise? -9. What's the very highest that it goes? positive infinity. So our range goes from -9 to positive infinity. And we put a square bracket on it because I can touch -9. It's right here, la-di-da-di-da, that is real answer. So our range has everything to do with our y values. The end behavior kind of combines them together. It looks at the relationship between my x's and my y's. So this is something we did back in Unit 1, but we also pull it back in for this. We usually write this as x approaches. I'm going to start with the negatives because I'm going to go from left. So looking at my left arrow, as x approaches negative infinity, as x gets real small, what happens to my y's? Where do they go? They go to positive infinity. They go in up. As x gets really small, my y's get real big. So as x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, as my x's get really big, if my x is 100 or 1,000,000 or 1,000,000,000, what's going to happen to my y values? Positive infinity. They're also getting really big. So domain looks at our x's in isolation. Range looks at y's in isolation, all by themselves. End behavior is looking at the relationship between them at the very end. What the heck was that for? Thank you. My iPad's in such a mood today. She's like, it's fall break time. Thank y'all. All right, our last one up here, because we're just going to finish out question number 1 here. Let's write the equation in vertex form. We tell you right here that A is either +1 or -1. How do we know if it is +1 or if it is -1? What is the difference between an A of +1 and an A of -1? So a negative A value would mean it would be reflected over that x-axis. So a positive A value is a happy face, and a negative A value is a frowny face. So is this a positive A value or a negative A value? Positive, because this is a happy face. Positive news makes us happy. So when we go to start to write our equation in our vertex form, meaning we want it to look like this guy, we're going to start with our y equals, and we've decided this is a happy face, so I'm going to put my +1. X minus, what's my h? X minus what? What are we going to put here? 2. My vertex is made up of the point h comma k every single time. So I have my h and k right there. So x minus 2 squared plus my k minus 9. So really the only choice we have to make is this is a happy face or is it a frowny face, and plug in our vertex. Okay? A little clear? Cool. I know it was more things than you asked for, but it just didn't make sense to start in the, it didn't make sense to start in the middle on there. I'm like, I need the vertex anyway. There's only one question before it.
Okay, I need the last.
Yep.
For these?
Yep.
Are you using, this?
Yep.
Okay. It's the one where it's like the negative and the positive equation.
Correct.
and stuff?
Any others you want to work through specifically? Well, one of these ones down here? Yeah. Yeah. I'm going to get you pass. There you go, dear. All right, I'm gonna do the first equation because I actually wound up with a typo on the answer key, so I'm gonna do the first equation. Look at that. So I'm gonna look at A. I tend to do it from the equation to the picture instead of from the picture to the equation. It just makes things a little easier.
Excuse me, is it C also right here?
Oh, yes. There is, in fact, a typo in our quadratic formula on the review. I did not even notice that. There should be a C right there. On my review, it has it. Why is it not on yours? I love that. That's so much fun. Make sure your quadratic formula has it. I will triple check every single test to make sure it has all the formulas correct. That's fun. That's glad I didn't write it. All right, so when we're looking at these equations and trying to match them to graphs, we have several pieces we can use. When we are in our standard form here, we can use our y-intercept. Our y-intercept is always going to be that c value. So this first equation is going to have a y-intercept at 0, -8. It's always this c value. We have a positive a value, so just like we saw up here, we know this is going to be a happy face. But because my a value is positive. If I have a negative out in front, like on equation B, that's going to be a frowny face. That arrow looks crazy pants. There we go. So unfortunately, the two happy face graphs we have both wind up with y-intercepts at -8. So I don't quite have enough to tell me just off of this. Switch that -8. There we go. Just because that 8 looked crazy. So what we can do, since I don't have enough to tell between these two happy face parabolas, because they both have intercepts at -8, I'm going to look at my axis of symmetry. So that equation is up at the top in our formulas here, and it is one we give you. It's the littlest one. So our axis of symmetry is the tiny one, that guy. So we're going to find our axis of symmetry, which happens at x equals the opposite of our b. What's our b here? On the yellow one? -2. So the opposite of -2 over 2 times our a, which is 1. So opposite of -2 gives us a +2. 2 times 1 is 2. So where's our axis of symmetry? What is 2 over what is +2 over +2? 1. So which of these graphs here, G or H, has an axis of symmetry at +1? H. So this has our y-intercept at 0, -8. We have our axis of symmetry at +1, and it is in fact a happy face. So this matches up with equation number A. Or you can say this guy matches up with graph H. So it's going to be easiest to go from equation to picture than to go from picture to equation. Sometimes the smiley face, frowny face, y-intercept is enough to tell it. In this case, it didn't. So you just have the other 3 to go on there. Okay. We've got about 8 more minutes. You want to pick one more? Yeah. They're just chit-chatting. 9. These ones are very much like the bell work. So these ones in particular, D and E, are just like the ones we did in the bell work. Distribute. F, G, and H are just like the 2 we did in the bell work. So let's do A. And I guarantee what's happening is you're overthinking it. Guarantee. Because I have 2 pieces here that are being added. Are my parentheses actually doing any work? No, they are in the way. I am removing them. We have 4 plus 2i plus 5 minus 8i. We're combining like terms here. That's all it is.
Wait, so do we always take the parentheses off?
You don't have to, but when we're just adding these together, the parentheses aren't actually helping me. So all we got to do here is combine like terms. 4 plus 5 gives me 9. 2i minus 8i minus 6i. The only difference between the addition and the subtraction, when we might need to keep our parentheses for a hot second, is because we have to make sure we subtract this whole thing. It's still that we're subtracting. It does not magically turn into multiplication. I had a lot of people do that on the homework. This just becomes negative 4 plus 3i minus 6 minus negative 4, which is plus 4i. So adding and subtracting is just combining like terms. When we're subtracting, we just have to be extra careful about signage. Because this one should wind up with negative 4 and negative 6 being negative 10, and 3i plus 4i giving us 7i. H is 100% just like the ones we did in the bell work today. It's square rooting and pull out the i's. So, like we can take our square root of negative 1 times 27, square root of negative 1 times 9. So we're going to have our I. Square root of 27. It's not a perfect square, but it should give us 3 square root of 3 times I times square root of 9. That's 3. We can multiply these two things together in the calculator, and we just need to pay attention to our i's because we have an I squared here. I times I. So this should wind up with us as a negative 1. That's from my I squared. And if you multiply our 3 times 3 square root of 3, we're going to get 9 square root of 3. These two pieces we can type in the calculator and multiply them together. What's that?
You know how like you put these? What
Yep.
are these ones?
Standard form is on the left, or general form.
Mm-hmm.
And the middle one is factored form.
Okay, standard and factor.
Correct. Yes, dear.
How would I start this?
So that one, you're going to want to get your x squared by itself. Since we don't have a middle x, we're going to want to get it x squared equals meh, so that we can square root both sides.
Oh, okay. But then, so what it would be like plus minus square root of negative 9, and then I would say equals to 0. Oh, so I was doing that.
Yeah, you're doing great. You're doing great. Which one were you looking at, Danae? D? That's just like the bell work one, where we distribute it or we box multiply it. So this guy, that guy. So distribute it and just watch out for those I squareds. Okay. I do have the full answer key to this posted up on the Canvas page. And for all the homeworks. So as you're going through stuff, do so. So one thing I want to point out, we just got like 2 minutes left. On something like number 8, where we're asking to use our quadratic formula, what is the first step we have to do? Super duper important. Set it equal to 0. Our very, very first step has to be to set this equal to 0. So we're going to have our x squared plus 12x minus 8 equals 0. Then we can find our A, B, and C and substitute it in just like we've done before. We have 2 minutes till the bell.